Welcome to the lecture on flowcharts. In the previous class, we have studied what are algorithms, how you can compare algorithms with pseudocodes, what is meant by pseudonym. When I was teaching you pseudonym, I could have explained to you with more examples. Pseudonyms like names are there, film actors' names, no. Dilip is a pseudonym of somebody else. His name is something else, right? Same way, pseudonym means a false name or a name that is not the original one. So we have seen what are pseudocodes. Pseudocodes are the programs or the codes that are not executable, that are something that is written in a language that is more understandable by a programmer. Now, next important topic in your syllabus is about flowcharts. What is a flowchart? Flowchart is a diagrammatic representation of an algorithm that depicts the flow of the program. I told you already that we have something called as a structure for programs, right? How the structure works is called as a flowchart. What is the first step? What is the second step? What is the third step? And so on. Like we have graphical representations for mathematical equations. Y is equal to mx plus c is a very famous equation for a straight line. Am I right? Similarly, we have a graph for that. Similarly, we have a diagrammatic representation for algorithm which we call it as flowchart. Okay. So what are the kinds of symbols that is used in flowchart to represent different kinds of steps in your algorithm? Okay. This is called a start. We have an closed ellipse. Both the start and end modules are represented by this kind of symbol, and in this symbol if you have written start, it means that you have started the algorithm. Second one is a rectangle to represent any kind of mathematical equation or any kind of operation, arithmetic calculations or any kind of operations generally. Say for example, you want to write an equation, you can use a rectangle. A parallelogram for input-output operations. To read a value or to print a value, to take some inputs or to declare some inputs, we use parallelograms. Okay, a rhombus or a diamond shape for any conditions like if statement and so on. These are the basic diagrams. These are the basic shapes that determine how an action has to be taken in a flowchart. I told you flowchart is a diagrammatic representation of algorithm. So you are using algorithm and you are representing it in terms of different kinds of blocks. So we'll proceed into the next set of symbols that is used in flowcharts. The next set of symbols that is used in flowcharts. When we are writing big programs or when the algorithm is big, what we need it to be splitted into modules. So a rectangle with vertical slides represent a module. We'll be having two side lines in a rectangle when we create a module. While writing different programs like finding out the largest number among a group of numbers, we have come across loops. Loop means we are executing a set of statements or a block of statements for n number of times. Okay, that is called as a loop. One set of statements, you wanted this set of statements to be repeated until and unless you say that is a for loop. Right? For example, you have a list, you want to start from the first to the last, it is called as a loop. Right? So that is a loop. Then we have a flow lines that you know already, arrow marks indicate flow lines. Then we have on page connectors. Suppose you wanted this to be connected to the other pages, you can use on page connectors, and off page connectors are denoted by this particular symbol. So in your exams, you may be asked to draw flowcharts, which you need to do. Okay, we'll see how to draw flowcharts with examples. So this is a very simple question. Write an algorithm and draw flowchart to find simple interest. What is simple interest? The principal amount into number of years into the rate divided by 100. So in that case, what we are taking input. This is the algorithm. On the left side of the screen, you can see there is an algorithm that says begin the program, read the values of principal, rate and years. Then we are finding out the simple interest, principal into rate into years. Then we are dividing it by 100 because we are simply applying the formula for simple interest, and then we are printing simple interest. Then we are concluding the program with a, concluding the algorithm with a stop statement. So let us draw a flowchart for this. Flowchart means we have to put these things in order, and there should be a flow. We have start here, we begin the program, it is a rounded ellipse. Then we have in parallelogram, we are reading, taking input, we are getting the values of principal, rate and years. In the rectangle box given in a rectangle, we are calculating the simple interest. SI is equal to principal into rate into years by 100. Again, for input and output, we are using parallelograms. We are printing simple interest in our output. Then we are concluding the flowchart. So this is how you can draw a flowchart for a simple algorithm. You may be asked to draw flowcharts for simple algorithms in your exams, and you may need to do it. First, we'll get the principal amount from the user. So what is principal? Usually it will be in a decimal number, right? Decimal number, am I right? So for decimal data types, we use float. Input enter the principal. What is the principal amount? So here what we are doing is that we are getting the input from the user, and we are converting this input into a float type because we'll be having decimal numbers. You can put 10,000.25 or whatever it is in your principal amount. When you run this statement, what happens? When you run this statement, what happens? The program will ask the user for the input. What is principal that you are going to invest, for which you want to find out the simple interest. So let's wait for a second so that the statement is executed. So it is asking for the principal amount. I can give it as 10,000 or something like that. Okay, I can press enter. So principal is 10,000. That's it. Next thing, we need to get the rate of interest. So we'll call it as rate. You can give this, these are all variable names. Whichever is convenient to you, you can give. rate is also a float, and input rate same, and similarly number of years you are investing, years can be integer, input years, years. So the system is asking me for the rate of interest. I'll put it as 11.5 for example. Next it will be asking me how many years you are going to invest. I am saying 5 years. So now what is happening is that we can see how it works. Principal, comma, rate, comma, years. These are three different variables. One is principal, one is rate, and the other one is years. So I am printing out all the three values. I am using Colab, so I don't need to use print statement. When you are doing it in Spider, for every of these things you should use print statement, that's all. Okay. Now what is that? Next one we need to find out simple interest. Okay. We can give it as SI. SI is equal to simple interest. SI is equal to principal into rate into years divided by 100. Okay. And then the last step in the program is to print the simple interest. So we have printed the simple interest and the value is to be 5,750. So next we are going to write an algorithm and draw the flowchart to find which number is larger given two numbers. So the input here is two numbers. Let us call these numbers as A and B. Let us give these variables as A and B, or let us call these numbers as A and B. In the algorithm, what we are doing is that we are reading both A and B. The second statement, after you have started, you are reading A and B, checking out whether A is bigger than B or not. If A is bigger than B, this statement that large is equal to A is executed. Please keep in mind that if statement follows with a condition, and after the condition what it says is that if A is larger than B, the value of the variable large will be A. Otherwise it will be B. Else it will be after this block. This is called as a block. So after this is there, it will get executed this one. Large, otherwise the large is B. Okay. Then what we are going to do? We are going to print that large number. This is the algorithm. In flowchart, we have begun the flowchart with the rounded ellipse for start, parallelogram for reading A and B. This is an important thing. You are going to decide whether A is greater than B or not. If this point is true, if this is true, then it will print A. If this is false, it will print B. I forgotten to write here true and false. So you can write that if it is true, this statement will be executed. If it is false, this statement will be executed. And you are concluding the flowchart. So this is how you draw flowcharts. Flowchart to draw for an algorithm to find which is the larger among two numbers, these two numbers given A and B. I am implementing this also in Spider itself. All of you listen here. A is the first number. I wanted to get it inputted from the user. I want A to be, I'll call it as integer or float, whatever I like, because it can be integer or float. I just wanted to find out which number is bigger. Input, enter the value of A. The next one, enter the value of B. So I've got both the values A and B. If A is greater than B, if A is greater than B, see, here you should remember that there is an indentation, there is a space given, it is not in the same line, and those things are called as blocks. Okay, print F A is greater than B. There is no colon, there is colon at the end of if statement to indicate that there is a block that is going to begin. Else print B is greater than A. Okay. Are you all able to see this code? You can come this way. Now, if I run this, what is going to happen? Let me show you. I'm going to run this. So it is asking me enter the value of A. I am putting it as 3.8. Enter the value of B, 9.6 or something like that. And if I run this program, what I'll get? 9.6 is greater than 3.8. What is known as math module? It's an introduction to math module where you can do a lot of mathematical functions. In order to use any module or any package in Python, you have to initially import that package. So we'll import math. A is equal to say 20.6. Now let me print the square root of maths of A using math module. Math.sqrt A F the square root of A is math.sqrta. We have a package called as math. Inside the math there are so many built-in functions. So one among that function is called as sqrt, which is going to give you the square root of any value that you are going to enter. Okay, so here I have declared the value of A to be 20.6 and I am printing the value of square root of A. So I get the square root of 20.6 to be 4 point something. Square root of, if you want to test this program, you can give this as square root of 16 and see what would be the answer. You will get it as 4.0. You can give any values to find its square roots. 30.9 and so on. Okay. So listen here. Math has another module called as exp of A, which is going to give you the exponential value of A. Okay, if you run this program, exp exponential value of A, exponential value of A is exp of A. So all kinds of mathematical functions you can do. If you want to find the logarithm of A, log A, you'll get the logarithmic value of A, logarithmic value of A. If you want to do, you can use math.log A. Suppose you want to find, this is for exponential and logarithmic. You can do it for trigonometric functions also. So if you want to find sine A, you can do sine of A. if you want to do cos of A, the sine of A, the sine of A, if A is 0, what is sine 0? Cosine. Cosine. Cosine of 0 will be 1, right? Yes. So these are the basic trigonometric functions, logarithmic functions, exponential functions. All functions you can use math module and you can get the relevant values. So thank you all. Thank you very much.